a continuation of this series, and in this part we are going to look at relative density. Now, relative density refers to the ratio of the density of a substance to the density of water. There are different formulas used to calculate relative density, so let's look at some of them. So relative density equals density of substance over density of water. Relative density could also be mass of substance over mass of water. It could also be volume of substance over volume of water. We could also have the weight of a substance over the weight of water. So it's always comparing a ratio of a quantity of a substance or an object to that of water. So let's start solving the questions. Now, there's something you need to know about relative density. Now, relative density of water is either 1000 kilogram per meter cube or 1 gram per centimeter cube. So if the question has to do with kilogram per meter cube, you go with this. If it has to do with gram per centimeter cube, you go with that. Okay, so looking at this question, an object has a density of 2500 kilogram per meter cube. What is its relative density? Now you can try it. You can pause the video, try it. Alright, so relative density equals density of objects. In the case of this question, is an object. Density of object over density of water. So the density of the object is 2500 over density of water. Now we are not going to use the 1 gram because I mentioned already at the beginning of this series that you are always going to be careful of the units that are involved in solving. So it's kilogram per meter cube. So kilogram per meter cube, 1000. So when you punch this on a calculator, you're going to have 2.5. Now take note, relative density does not have a unit because now the kilogram per meter cube for this, the kilogram per meter cube for this will cancel out. So take note, relative density does not have units. So that's it for this question. Now in the next one, a substance of mass 20 grams displaces 15 cm cube of water. Find its relative density. The volume of water displaced equal to the mass of water displaced. Relative density equals, over here we are dealing with mass. So the mass of the substance, over mass of water. So mass of substance is 20 grams. So this 15 cm cube will actually be 15 grams. So when we cancel out, you are going to have 1.33. That's the answer to this question. Now to the next one. A block floats in a liquid with relative density of 0.8. If the block's relative density is 0.5, what percentage of its volume is submerged? For a floating object, the volume of submerged over total volume will be equal to relative density of the block over relative density of liquid. Now, the block has a relative density of 0.5 over the relative density of the liquid is what? 0.8. So you realize that with relative density, you are always dealing with the ratio of the substance to the liquid. Over here is in water. So the formula for relative density could also be relative density of substance over relative density of water. Over here it's a liquid. We are going to have 0.625. Now we ask what is the percentage. Now to get percentage, all you have to do is to multiply this by 100. We are going to have 62.5%. So 62.5% of the block's volume is submerged. So I guess you can try this. You can pause the video and try this question. So if the mass of an object is 30 grams, it displaces 20 grams of water. Calculate its relative density. So with this, relative density equals mass of object over mass of water. So the mass of the object is 30. The mass of the object is 30 over mass of water is 20. So work it out, you're going to have 1.5. Then the last question. A liquid has a density of 850 kg per meter cube. Calculate its relative density compared to water. Now with this, we have kilogram per meter cube, and I already mentioned that relative density of water is 1000 kilogram per meter cube. Sometimes it will not be given to you in a question, so take note. So relative density equals, always say the formula, density of liquid over density of water. So 850 is for the liquid, then 1000 is for the water. We're going to have 0.85.